All right, let's look at this sheet. Here we have neutralization of acids and bases. So I am going to mark this up as I read it. Dissociation of water. So remember, dissociation is going to mean the breaking apart. So just for example, sodium chloride, when I add it in water, is going to break apart into sodium ions and chloride ions. When water dissociates, one hydrogen loses an electron and becomes a hydrogen ion. So when water dissociates, we get a hydrogen ion. And the other hydrogen atom becomes with the oxygen, becomes a hydroxide ion. Okay? Since the hydrogen ion has no electron to neutralize the positive charge on its proton, as a full unit of positive charge and is symbolized as H+. The hydroxide ion retains the electron that was left behind and thus has a full unit of negative charge symbolized by OH negative. But this right here, this guy, the hydrogen ion, does not wander around very long by itself before it attaches to a water, and together they become a hydronium ion, H3O+. Okay? In any sample of water, very few of the molecules are dissociated at any one time. In fact, it's about 1 in 550 million. Tiny, tiny, tiny. There is, however, a constant change. As one hydrogen ion reattaches to a hydroxide to form water, so it's going in both directions. It's going forward like this and then reverse like this. And then another water molecule dissociates, okay, so it is just consistent. All right, so let's look at hydrochloric acid. Certain molecules, ionic and covalent, dissociate in such a way that they release a hydrogen ion without releasing a hydroxide ion. Okay? These substances are called acids. So acids are going to produce H pluses as their only positive ion. This is the Arrhenius definition of an acid. But remember, these rarely hang out by themselves. So we could also say that acids produce hydronium ions. Okay? Since a hydrogen ion is really just a proton. Why? Because a hydrogen atom has one proton in the nucleus and one electron. When it loses that electron, it just has a proton left. So the chemist's definition of an acid is a proton donor. If very many protons or hydrogen ions are donated, the effect can be very profound, such as it can burn your skin or dissolve metal. This acid illustrated is hydrochloric acid. So pure hydrochloric acid is a gas, but it dissolves easily in water to produce a solution of hydrogen ion and chloride ion. So HCl dissociates to have hydrogen ions and chloride ions. Since nearly all of it is dissociated in water, it is called a strong acid. Acids that do not dissociate completely are called weak acids. All right, sodium hydroxide. The opposite of an acid is a base. It's also known as alkali. That's why basic solutions are called alkaline. A typical strong base is sodium hydroxide, the principal component of lye. It's also used to make soap. Sodium hydroxide dissociates, so we have sodium hydroxide dissociates to form a sodium ion and a hydroxide ion. A base is defined as a proton acceptor. Now in Arrhenius theory, a base is defined as something that produces OH negative as the only negative ion in solution. But the Bronsted-Lowry calls it a proton acceptor. The most common bases produce hydroxide ions when they dissociate like this one, and it is the hydroxide ion that actually accepts the proton. A strong base can give your skin a much worse burn than an acid. Now, when a base and an acid are mixed, the hydroxide ion from the base combine with the hydrogen ion from the acid to form water. All right, so why are acids called proton donors? All right, so let's get to, we have just a few questions down here. Oops. So why are acids called proton donors? Okay, so why are they called proton donors? Because when acids dissociate in water, they release H plus ions, and an H plus ion is a proton. So it's the same thing. What happens during neutralization? Okay, so you can write this in words, or I'm going to write an equation. I'm going to have a hydroxide ion combine, it's in aqueous, meaning it's dissolved in water, combine with a hydrogen ion dissolved in water to form a water molecule, and we use L, liquid, to identify that. All right, complete these neutralization reactions. So in class, we talked about what happens. So the OH from the base combines with the H from the acid to make HOH, which is H2O, which is water. So an acid and a base are going to give water, and then a salt, and the salt is what is left. Okay, so if I switch the color, then right here, this is what's left, KNSO4. But what I have to do is make sure I look up the charges. So if I go to the periodic table, the charge of K is +1. The charge of SO4 from table E is -2. So if SO4 is -2 and K is +1, these do not balance right away. But if I add another K, that gives me 2 positives and 2 negatives. So my formula is going to be K, how many did I need? 2. And then 1 SO4, that stays as a group from table E. Now I check and make sure things are balanced, right? So how many K's do I have on this side? 1. How many K's do I have on this side? Oh, that's a problem. So let me just switch colors so we're not being confused. I'm going to put a 2 here. Oops, not there. On the other side. Okay, so let's go back here. All right, so I want to put a 2 on this side because I have 2 K's over here, right? When I put a 2 there, now I have to pay attention, okay? So that gives me 2 K's, which fixes it. Let's see how many oxygens. I have 2 oxygens and 2 hydrogens. Over here, now I have SO4, I have 1 SO4 right here and 1 SO4 right here. So SO4 is good. Let's see if I can fix the rest. I have 2 hydrogens here. So that gives me a total of 4 hydrogens and 2 oxygens. Well, if I do this, that gives me 4 hydrogens and 2 oxygens, and I'm balanced. All right, so let's look at the next one. Ready? The H from here and the OH from here make HOH, which is water, because an acid and a base combine to make water and a salt. So what salt? Well, let's find out. We have NO3 and Ba. I need charges, okay? So let's find a space. So Ba is 2 plus and NO3 is -1. So I need another NO3, right? That'll give me 2 negatives. So my formula is going to be Ba, and then in parentheses, I put the NO3, and I need 2 of them, so the parentheses goes outside. All right, now we have to check for, is my equation balanced? All right, so how many NO3s? 1. How many NO3s? 2. So let's try this. Put a 2 here. All right, 1 Ba. So ideally, I still have 1 over here. I don't want to mess that up. So let's just count H's and OH's that aren't in NO3, because NO3 we just balanced, okay? So I have 2 H's over here. On this side, I have 2 O's and 2 H's. So that gives me 4 H's total and 2 O's. Can I make this be 4 H's and 2 O's? I sure can, like that. All right, so there is the neutralization. So now let's look at the back. So first we have right here the dissociation of water. It says hydrogen should be yellow and oxygen should be red. So now you can color these completely in, right? Or outline them, okay? So oxygen is red. So in water, I have 1 oxygen, right? So this is the oxygen here. Over here, this represents my oxygen in the hydroxide. See, that's OH. I'm just outlining and shading it, okay? So here is in water, like this. Here's my oxygen. No oxygen here, and then hydronium has 1 oxygen. It's 1 oxygen right here. Okay, now I need to switch colors and I need yellow for hydrogen. So I have 2 hydrogens in water, right? H2O, so like this. Now if you want to make yours neater, totally fine, you can do that. But we are just shading, outlining and shading. So see, this water breaks apart, dissociates into this, and then when a hydrogen ion or a proton finds a water molecule, it attaches to it and forms a hydronium ion. So when we talk about acids, we talk about H pluses or protons, but in reality, it's the same thing as talking about hydronium ions, because hydrogen ions aren't going to stick around by themselves for very long. All right, so there's the dissociation of water. Now let's look at the next part. It says acids and bases. So let's first color the things that we had already. So H's, that's what I was just doing. So I have an H here. I have an H here. So I'm going to do these the same as I did before. Here's the H. Okay, and here is the H. Okay, then what did I do the O's? The O's were red, right? So let's go back. Here is one of them, right? Because that's an OH negative. Where else? Oh, here it is. I don't have any in the first equation. So you notice whatever I have, on the first side, I'm going to have on the other side. Okay, let me just erase this. I kind of zoomed in for a moment. All right, so let's look, just so I know the colors. Okay, so I need chlorine is green. So let's choose green, and here's one of my chlorines. So if I have a chlorine on this side, I've got to have 1 on the other side, and here it is. Okay. And then sodium is blue, so now I need to switch to blue. And I have a sodium here on this side, and if I have 1 sodium here on this side, I have 1 sodium on this side. Okay. So something else that I want to point out to you is that charge is always balanced, because we have conservation of atoms. So we have the same number of atoms on both sides, but we have conservation of charge. So let me just switch to a different color so as to not confuse you. So I have a positive 1 and a negative 1, which is 0. On this side, I have a negative 1 and a positive 1, which is 0. It should balance on both sides. So this side is 0. This side has to be 0. Same thing here. That's a positive 1 and a negative 1, which when you add them, you get 0. On this side, I have a positive 1 and a negative 1. So when you add them, you get 0. So charges have to balance. Okay. So now we have one remaining question. It says draw and color the neutralization reaction between hydrochloric acid and sodium hydroxide. So hydrochloric acid is HCl and sodium hydroxide is NaOH. And that's what we kind of just did in pieces up there, okay? So if I write it just as an equation, it is sodium hydroxide. So hydrochloric acid and sodium hydroxide yields, I always know I get water, right, from the OH and the H, and a salt. So what do I have left? I have NaCl. And if I check charges, this is +1, this is -1. So that's it. I don't have to add any coefficients. It is balanced. So this is the equation. And now I need to draw it. So you're going to use what you have up here to draw it, right? So you need a Cl connected to an H. You need an Na connected to an O, then an H, okay? Over here, you need an O connected to 2 H's, and here you need an Na connected to a Cl. And then you are going to color them according to the same key you used above. So I'm not going to do that for this one, but you should be able to do that. So let's just add this and this to make it accurate. And there you go. That is your neutralization sheet, okay?